Hello everyone, I am Cécile Perrault, the R&D Director in EdTech, and this presentation will allow you to discover our microfluidic water treatment system and its possible application for the WATERAGRI project for recovery of micronutrients. Our company, EdTech, was created in November 2017. Our mission is to develop microfluidic solutions for industries to make them more sustainable and accessible. Our innovative approaches have been rewarded by national and international agencies, such as the European Commission, and in 2019 we were selected in the top 10 most disruptive startups in France at the iLab competition. Our solutions allow any system that circulates fluids, whether it is for making new drugs, or food mixing, or water cleaning, to be more sustainable, requiring less energy and space. With our solutions, all chemical processing becomes readily accessible and environmentally friendly. We can miniaturize all those fluidic processes because we use a technology called microfluidics. If you think about chemical reactions, you know that they are the results of two or more elements coming together. In microfluidics, all the tubings and reservoir were reduced into micron size, and they bring those elements together more easily, and their interactions are renewed more readily. Therefore, in a microfluidic system, all reactions are accelerated and the equipment is reduced in size. Our solutions are inspired by the use of microfluidics in nature. For example, our body circulates 5 liters per minute of blood through a system of millions of capillaries with diameters smaller than 10 micron. Our pump, the heart, creates pressures at 0.2 bar, which is quite low. And our kidneys filter our blood in a functional volume of 4.5 milliliter. To compare, the most efficient water treatment solutions, reverse osmosis, requires 300 times more pressure and 300,000 times more space to treat the same volume. Our strategy is to use nature's ingenuity to achieve similarly exceptional performance. We design microfluidic circuits with the same physical principles, and we transfer them by embossing CD-shaped elements made of thermoplastics. The CDs are then stacked into a tower to create our cartridge, which is then inserted into our overall water treatment system. Using microfluidics, we are able to capture nutrients at low concentration in a compact system that uses over 95% less energy compared to traditional advanced treatment methods. It reduces cost at the initial investment, what is called capital expenditure or CapEx, and during operation, called operational expenditure or OpEx. And most importantly, we help Europe achieve its ambitious and world-leading goals of its Green Deal, providing cleaner water while using little energy. Our compact solutions open new opportunities to deploy treatment solutions in remote locations and achieve purification even when the elements in the water are at low concentration levels. In WATERAGRI, we evaluate the possibility of capturing and reusing micronutrients from water. In agriculture, crops are often supported with the use of fertilizers that provide nutrients such as nitrogen, phosphorus, and potassium in large concentration. However, if other essential micronutrients such as sulfur, boron, zinc, iron, calcium, copper, magnesium, and manganese, if they are not available, crop responses to fertilizers will be low. So new products were developed to include micronutrients in fertilizers at low concentration. But a major issue faced with fertilizers is the pollution they generate in water. Fertilizers runoff have caused massive environmental crises through the world, from algae blooming in Florida to pollution of potable water in France. There is a push to require treatments of water streams from farm with the opportunity to reuse the removed nutrients in a virtuous cycle of agricultural practices. Because nitrogen, phosphorus, and potassium are found in large concentration in the runoffs, they were first targeted for reuse, and the financial viability of those solutions have already been studied. However, for micronutrients at lower concentration, little is known of their presence and concentration in agricultural runoffs and their economical potential. In WATERAGRI, EdenTech is in charge of assessing the financial viability of micronutrients capture and reuse by analyzing water from our pilot sites. The concentration levels of micronutrients in this water will allow us to establish whether their recovery is technically achievable and financially worthy. I thank you for your attention and welcome any questions you might have about our solution. We look forward to seeing you soon.